So the first type of review question you're going to have is solving an inequality. Now for now, let's just think of this as an equal sign, because it's going to work the exact same way. We're going to follow the exact same process. We want to follow our order of operations. So I'll need to multiply here in the parentheses in this distributive property with a 12x and a 12 times negative 3. So 12 times x is 12x. 12 times negative 3 is a negative 36. Drop everything else down, keep it all the same. Minus 11x equals 9. Sorry, this should be an x. Next thing we want to do is combine like terms. So I have a 12x and a minus 11x. That's going to give me just an x minus 36 equals 9. And the last thing I need to do is to get x by itself. I want this to be an x equals problem. So what's the opposite of subtracting 36? That's adding 36. And that gives me a 45. So now I have x equals 45. Of course, this was not an equals problem. This was an inequalities. So we'll go ahead and change it back to greater than and equal to see that not much has changed. Except for the fact, if I were to, let's make that at 2. If I happen to divide somewhere along the line by a negative number, I would then have to flip the inequality. Or same thing happens if I were to multiply across inequality with a negative. So if you multiply or divide by a negative, please remember to flip the inequality. Didn't happen here, so we're okay. I get x is greater than or equal to 45. So once we get our answer that x is greater than or equal to 45, the two things we want to do is first graph it. So I'll write my 45 here. Greater than or equal to. Remember with our notation, if I happen to have a greater than or less than, I want to use open and close parentheses. Yet if I have a greater than or equal to, I want to use open and closed brackets. So for here, since it's greater than or equal to, I want to use open brackets. And what are all values greater than 45? Well, they're going this way, 46, 100, all the way to positive infinity. Positive. Now that we graphed it, the next thing we want to do is to write our answer in interval notation. Which means basically take your graph and write it shorthand. So what's the first number I come to from left to right? In some cases it may be negative infinity, but in this case the first number I hit is a positive 45, which I have open brackets. That is my smallest number on this graph. So comma, what's my largest number on this graph? Well, my largest number, you can't get any larger than infinity. And can you ever reach infinity? No, you can never equal infinity. So you're going to always use parentheses with anything associated with infinity. So here my answer in interval notation would be open bracket 45, which is the smallest number, comma, infinity, close parentheses. Note that it's going from smallest to largest and how it reads your graph. So the next type of inequality we're going to look at is a compound inequality. Compound inequality is basically two inequalities on the same number line. They're either going to go out in opposite directions towards the positive and negative infinities, or they're going to overlap like so. And we're going to be looking for the intersection of the two. So think of it as two inequalities on the same number line. Now with this example here, we're going to look at an absolute value compound inequality. I have the absolute value of x plus 2 is less than 4. Now like you saw in class, I want to break these guys out of prison. When you're on a number line, and I'm standing at 0, which directions can I go? Well, I can go in two directions. And we want to show that by writing what's inside here in two directions. So x plus 2 and x plus 2. I can go on the left side of the number line and on the right side. Now also, when you're going this way on the number line, you're going towards the positive numbers. So you're going to look at this number here and write the positive value of that number. Now you can also go on the other side, towards negative infinity, towards the negative side. So you want to write the negative version of this number. So I'll have a plus 4 and a minus 4. This represents the two directions and the two sides I can go on the number line. Now let's look at the inequality. Here, x plus 4 and a positive 4. Did anything change? Did my signs change? No, I stayed as a plus 4. So my inequality is going to stay the same. Now what happened over here? Note that I now went from positive 4 to negative 4. And what happens when you multiply or divide across an inequality? Well, the sign flips. So where you change the value of this last number, you're going to have to change the sign. And now it just becomes two inequalities that you can solve separately. So solving for x, opposite of multiplying adding 2 is subtracting 2. Gives me x is greater than negative 6. And here, I want to subtract 2. X is less than 2. So notice how, like I said, with compound inequalities, you get two different inequalities. X is greater than negative 6, and x is less than 2. Now, what would this look like on a graph? Let's see. So I have my two numbers, a negative 6 and a 2. With negative 6, I'm greater than negative 6. Greater than sign, I don't see the equal, so I'm going to use parentheses. And I'm all values greater than negative 6. Now over here, x is less than 2. Not equal sign, so I'm going to use parentheses again. X is less than 2. And notice how they intersect. That's the graph we want. We want where these two intersect together, taking both values. So the graph would just be this pink area. Now how would you write this in interval notation? Just give me the smallest number. Do I have parentheses or brackets here? Parentheses. Give me the largest number. And I have parentheses. So the value for this inequality is open parentheses negative 6 and 2. A couple things to watch out for with compound inequalities. If you have a less than, well, that's going to be a graph that connects. They're going to be graphs that turn in and they intersect, a less than type of problem, which your inequality is going to be one that has a one whole answer. Or else, if you notice you have a greater than, you can automatically assume that it's going to go out to your great values. I'm going to go out to my positive infinity and my negative infinity. And your answer is going to reflect that. You're going to have to start from negative infinity, have some value, parentheses or brackets, and it's going to be the union of that other number going out to positive infinity. So notice how with a greater than, your graph is going to be separated. It's going to go out to the greatest values you could possibly have, positive and negative infinity. Likewise with your answer. With the less than, you're going to come in. They're going to come in together and intersect. And so is your interval notation. Now to help me explain domain and range, I'm going to use an activity I used in one of my high school classes. Now domain refers to, I want to know all the x values that happen in my graph. I want to try to box in going from left to right on my graph. As you see here, my graph stops at negative 3 and also stops here at 1. Between these values, I have my graph. Now range is the y values, your up and down. Where can I box in my y, my vertical values of my x? My y. I see it starts here at negative 4 and stops at 0. Notice when I'm talking about domain and range, I'm talking about what is the smallest value and what is the largest value. What is the smallest value first, largest value. So it's just like interval notation. As you see here, when we're looking at the domain, I'm looking at the what? The x values. So that's why this is boxed in from left to right. I want to know where does my graph start? What is my lowest value? In this case, it's a negative 5.1. What is my largest value? Where does it stop? It stops here at 5.5. So my domain is going from negative 5.1 to 5.5. You kind of want to make a visual in your head just like this, a box. Kind of the highlighted area being your graph. So as I look at this graph, I'm trying to find what is my domain. So I need to find what is my farthest left value, my smallest value. In this case, let's say about 4. What is my farthest right value? What is my largest value? In this case, we'll say 3. So my domain is going from negative 4 to 3. See how I boxed it in from left to right along the x-axis. Now the range does the same thing, but it does it vertically along the y-axis. So I want to know what is my smallest value, where I first hit my graph. Looks like I hit it here at, look at the y value, negative 1.7, and where does it stop? Looking like I stop up here at 0.49, so 0.5. So my range with the y is going from negative 1.7 to 0.5. You're doing the vertical box. So again here, what would be the range? The range is going from smallest value, 0, to largest value, 4. Let me box this one in. So find my smallest value for my range. So let me find the range here. First, I have to set my lowest value. Where does my graph start? Well, I guess we'll say 0.5. And where does it stop? What's my largest value? Right up here, we'll say 3. So my range from going in interval rotation is going from 0.5 to 3. That is the range of my graph. So this is kind of what you should be doing when So this is kind of what you should be doing when you're trying to find the domain and range. Trying to box in your graph here. So I need to find my domain. So what's my farthest left and right? Looks like I'm going from -2 to 1. And now let me look at my range. Box in the smallest value, -3, all the way to 3. And all this area in between, my orange and green, encompasses my entire graph. You don't see any of my graph outside my range and my domain. That's the whole focus of this, is where can you box it in like I did here. Next, we want to look at linear functions, and more specifically with slope-intercept form of a linear function. So we have my equation y equals mx plus b, where m here is my slope, that is usually written in as their change in y over your change in x, or the rise over the run. So I have my slope here. What is the change of my y value as I go up from this point to this point? And what is the change of my x value as I go from here to here? And then also with this form, it has this plus b, where this is my y-intercept. Now note that the y-intercept is not just a number, b, but it's also, what it really is a coordinate, where the x is 0. So for y-intercept, you should put a 0, b. Now, if we're given something in either standard form or any other form for a linear function, what we want to do is put it in slope-intercept form. I want it to have y equals something. So for here, I want to move everything over and have y by itself. So let me add 20 to both sides. That's going to give me 5x here plus 20 equals 4y. And then last but not least, what's the opposite of multiplying by 4? Let me go ahead and divide by 4 on both sides. Then I'll have my equation in slope-intercept form. Y equals 5 over 4 x plus 20 over 4 is 5. So when I'm asked, put this in slope-intercept form, I get y equals 5 over 4, which this is my slope, plus 5. And 5 as a y-intercept is 0, 5. Now, if we're given 2 points on a line and we're asked to find the slope, what we'll want to do is plug it into this slope formula here, where I have my y2 minus y1, the change in my y, over x2 minus x1, the change in my x. Now, it doesn't really matter which one you pick as your x1 or y1. I'm going to just call this one and this 2, because it'll work either way. So you want to plug it in directly, y2, so this is my y value here, this is my y2, so -5. Note that the subtraction minus comes with the formula, so minus y1, and here's my y1, so minus 5, all over x2, so here's my x2, which is a -2, minus x1, so a -2. Now we know 2 negatives makes a positive, so I'll go ahead and change that real quick. And then simplify. -5 minus 5 is a -10 over -2 plus 2 is 0. So my slope here is -10 over 0. And what happens if you try to plug this into the calculator? Well, it'll give you an error message. That's because you cannot divide anything by 0. So what this really is an undefined slope. A slope that goes straight up and down. So when asked for these 2 points, what's the slope? You would say undefined because your denominator is 0. Now it is okay if you have a 0 in the numerator. That's going to equal 0. Or you could call this a no slope. And what that looks like, that is a horizontal line. Where if you sit here and try to go somewhere, like slide, you're going nowhere. Where else here, this kind of slope, you're in trouble. Now say you're given a point on a line and a slope, and you're asked to find the equation in slope-intercept form that has this point and this slope. Well, the next thing you want to use is what's called a point-slope formula. So I have y minus y1, so I need to identify what is my y1, that's the y coordinate of your point, equals m, and that is my slope here, which I know is 2, times x minus x1. So I got to identify the x1 of my line. And then now it's just a matter of plugging into the formula. So y minus, again the minus comes with this formula, in this case 6, equals m, which is 2, times x minus 9. Now I just have a matter of doing some arithmetic and solving for y, get this in slope-intercept form. What I want to do is follow my order operations, distribute this 2. That's going to give me a 2x minus 18. I have x minus 6 on this side. And now last but not least, solving for y, opposite of subtracting 6 is to add 6 on both sides. I get y equals 2x minus 12. There is my equation in slope-intercept form that has this point. I can verify that by plugging in my x. 9 times 2 is 12, 18, minus 12 is 6. It works. And do I have the slope of m? I do. And what is my y-intercept? Again, y-intercept is a point, it's not a number, so it's not negative 12, it's 0. Negative 12 for my y-intercept here. Next, we're going to talk about function transformation, or how I'm going to move my graph around my xy plane. First, I want to look at adding a number inside my variable, in this case, or inside my operation, in this case, a square root. So we'll start with our standard square root, and as I are adding or subtracting numbers, you can see it moving along the x-axis. So if I have a number inside something, like inside absolute value, or in this case square root, or in parentheses, it's going to move from left to right along the x. Now note, I'm adding a positive value, a positive number, and it's moving left towards the negative numbers. That's because inside in math is talking about the difference. What is the difference of a positive number? Well, that's just staying the difference, a negative something. If I'm talking about the difference of a negative, well, 2 negatives makes a positive. So it's going in the positive directions. So you kind of have to flip your brain a little bit when you're talking about going from left to right. Because as I make that value a positive, it's going to go left towards the negative. A negative value inside of here is going to go towards the positive values. Now, what if I were to add numbers on the outside, such as my b value here? Notice on the outside we're talking about going up and down. Now this does say the same logic as a positive value goes up and a negative value goes down. And what happens if I start multiplying numbers? Because before I'm just talking about adding and subtracting numbers. Multiplying does what's called stretching and compressing the graph. So notice how, picture this as a rubber band. I'm stretching it vertically. It's making it skinnier. And as my graph gets now, we've been talking about adding and subtracting numbers here, either inside or outside. But what happens when I multiply it? If I multiply a number that's greater than 1, I'm doing what's called stretching my graph. I'm stretching, making it kind of skinnier, as it seems. Now, if I'm multiplying a number that's less than 1, like a decimal, I'm compressing it. The graph is getting flatter. And if this number happens to be a negative, you see here it does what's called a reflection. So, multiplying greater than 1, stretch. Multiplying less than 1 but greater than 0, a compress, and a negative reflects over the x-axis. So as I look at some examples here, I'm changing this to 1/5 times the square root of negative x minus 3. So I look here at my graph. First thing you want to do is to actually graph that and see how it changed versus its original function. I can see that as far as the x, it didn't go nowhere. It stayed on the origin here. But as far as the y, it shifted down 3, and it looks like it got what? Flatter. So it compressed And also it reflected across what? Not the x value, but across the y value. So it went down 3, it compressed because it got flatter, and it reflected across the y. I rotated this around my y-axis. Looking at another example, -5 times the absolute value of x minus 3 plus 2. Go ahead and graph that. And just see the transformation. So I see it shifted to the right 3. It went up 2. So here's my new origin. It got flipped upside down. So notice it reflected across the x. And it got stretched. You can see it being pulled. So if I look at the values here, I have a negative on the outside. That's a reflection. Number is greater than 1. If 5 be multiplied, that's a stretch. Inside of minus 3, so it went to the right towards positive 3, and went up 2. So I say with transformation, go ahead and graph your original function and graph the transformation and just see how the graph shifted from its original. Now likewise, when you're asked about symmetry, best thing you want to do is just to graph it. Is it symmetrical along the y-axis, the x-axis, or the origin, where it kind of flips here? So looking at this graph, our quadratic, how is it symmetrical? Well, I see if I take this side and flip it over this side, it'll be the exact same. And what am I being flipped over? Well, I'm being flipped over the y-axis. So this graph is symmetrical over the y-axis. You'll also want to look at the power, 2. 2 is an even number. So this is an even function that is symmetrical over the y-axis. Let's look at this one. How is this symmetrical? Well, if I were to take this piece, flip it over the y, and then flip it again over the x, I see that this side, this hump, will land right here. So this is what's called reflected over the origin when it gets flipped once and twice. You're flipping over the x and the y. Now look at this function. It is a 3, my highest power. 3 is an odd number, so this is an odd function. So odd functions are reflected over the origin, O for odd, O for origin, and even functions squared is reflected over the y. As I look at this one, negative x to the 5th, 5 is an odd number, so I would suspect that this is reflected over the origin, which it is, reflected over the x, and then reflect that over the y, gets me here. Last but not least, my highest power here is a 4, that's an even number. Evens should be reflected over the y, so as I bring up this graph, is it reflected over the y? I see that it is. Here's my y-axis, flip this side over this side, and I have that function. X, anything reflected over the x is not a function, so we probably won't hit too much of those in this class. Now we're going to jump into what's called piecewise functions. It's basically pieces of different functions all as the same one function. Now this is a little confusing to look at, decipher, because you have two different pieces of information. You have your functions here, and you have some inequality here, which represents the part that these functions are a part of. So if I'm trying to find f of -1, it's, for this side in America, used to read them from left to right. But in fact, these are designed for the Eastern cultures that read from right to left, because that's where this math was created, of course. So the biggest confusion is, where do I start with piecewise functions? First thing you want to start is with the inequality. Start here first. As I look at -1, I need to decide, where does -1 fit? Which of these three here? Well, of course, is it less than -1? No. Is it greater than 2? No. It only works here between -1, which is equal to x, and less than 2. So this should be the only part of the piecewise function you look at, which means this is the only part of the function I want to look at. So you're going to look at the corresponding, the one that's right next to, across from the inequality, it works. So this is the second, the second step. First step, where does it work in inequality? Second step, plug it into the function that represents the inequality. So I'm going to take my x squared minus 4 and plug in -1 for x. So now I'm going to plug it into here. So -1 squared minus 4. -1 squared is a positive 1 minus 4. And that equals a -3. Let's look at that again and let's find the value of f of 3. So first off, I need to look here. Step 1. Where does 3 work with these inequalities? Is it less than -1? No. Is it less than equal to, or sorry, is it greater than equal to -1 or less than 2? No. It is, of course, greater than 2. So 3 works here, which means I want to look across from the inequality at the function. And the function is what? There's really nothing to plug into here, no value for x. So that means what is f of 3? 1 for this piecewise function. That's it. All values here will give you the answer of 1. One more time, let's find f of -6. Again, I want to plug it into the inequalities first. I'm reading from right to left, unfortunately. Where does -6 work? Is it greater than 2? Nope. Is it between -1 and 2? Nope. Is it less than -1? Yes. -6 works here. So now I want to look at the function associated with all values less than -1. And I have 3x plus 5. So let me grab 3x plus 5. And now I have to plug in my value, -6 for x. That's going to give me 3 times -6 plus 5, which equals -18 plus 5, which equals -13. So what is f of -6? Plug into the inequality first that represents -6. That would be up here. Look at the function associated with -6, x is less than -1 for -6. So I'm only going to be looking at this function. All other functions no longer exist on this piecewise function, and I want to evaluate it for that function. So previously, when we were looking at linear functions, we were finding slope, putting in slope-intercept form. But what if it's greater than a linear function? How do we find the slope of that function, like a quadratic or a cubic? Well, you're going to use what's called the difference quotient. And here's the formula, which you know in my class, I'm going to modify. So what does this part mean? F of x plus h. That means you're going to take your regular function, f of x, and wherever you have the x, don't just put x, but have it a x plus h. And what does this part mean? Well, this is kind of deceiving. You're not just going to slap a minus in between the function. I'm going to rewrite this as we're going to add to a function whose values got multiplied by a -1. Like so. And if you multiply something by -1, essentially what you're doing is that you are flipping the signs. And then once I do that, then I'll just divide it by h. So first part, take your function, add h to all the x's, and you're going to add that to the function that you just flip all the value, the same function that you just flipped all the signs, and then divide that all by h. Now let's look at an example. I have my function here, x squared minus 5x. First thing I want to do is to find my x plus h. Now x plus h is everywhere I have an x, I'm going to replace that with the x plus h. So I have an x squared, so x squared minus 5x. I'm going to do that, I'm going to teach that. I fucked up in the beginning anyway. All right, now let's look at an example. I want to find the slope of x squared minus 5. So I'm going to have my function of x squared minus 5x. Now with this part, f of x plus h, everywhere I have an x, I'm going to replace that x with an x plus h. So notice how that worked. No longer an x, now it's an x plus h. No longer an x, now an x plus h. And I'm going to add that to the function where I flip the signs. So this plus x squared becomes a minus x squared, and this not minus 5x becomes a plus 5x. And it's all over h. So one of the hardest things here is to decipher the formula. Take your x, add x plus h, add that to your function that you just flipped all the signs for, all over h. Now you just basically got to use math to solve it or simplify it. So I have said this, I'm going to write this twice, x plus h, and use distributive properties. So it's x squared plus xh plus another xh. H times h is a plus h squared. Distribute my negative 5, so negative 5x. Distribute my negative 5, negative 5h. And I have my negative x squared and a plus 5x. All over h. Now let's see what we have in common. Looks like my x squares can cancel. My negative 5x and plus 5x will cancel. And what I'm left with is a h squared minus 5h, and I have two of these, two xh's, all over h. Now what does h squared, 5h, 2xh have in common? Well, what did I say over and over again? I said an h. So if I take out h for each of these, so that'll leave me with 1 left. That'll leave me with just a minus 5. And here, if I take away an h, I just have a 2x left over. And divide that by the h there, I see these h's will reduce to 1. So therefore, my final simplified answer is x minus 5 plus 2x. That's the slope of my function, x squared minus 5x. So let's look at that one more time. I have my function here, which I'm trying to find a slope, x squared plus 4x. It's not a slope-intercept form because it's not a linear function, so I'll have to use what's called a difference quotient to find my slope. Now, we have my function that I got to modify in two different ways. First way is to take my x squared plus 4x, and instead of x, I want to replace that x with an x plus h. Every place I have an x. Second thing I want to do is to add that to my function where I have to flip the signs. So instead of a plus x squared, I have a minus x squared. And instead of a plus 4x, I have a minus 4x. And to complete the formula, that is all going to be over h. Now if you establish it and you correctly put it into the formula, you want to evaluate. So this is written twice. X times x is x squared. X times h is xh. H times x is another xh. And h times h is an h squared. Take my 4 and distribute my 4 across here. That's going to give me a 4x plus 4h. I'm subtracting that to an x squared and a minus 4x all over h. Now I can start simplifying. My x squares and x squares will cancel. 4x and negative 4x will cancel. And it looks like I'm left with h squared plus 4h plus 2 of these. So it's 2xh all over h. Again, you can factor out h that they have in common. You'll leave with 1h here plus 4 plus 2x all over the height. This will reduce to 1. And your final answer, your slope of this function is h plus 4 plus 2x. Or you can rewrite it a different way, however you came up with it. So h plus 2x plus 4 or 2x plus 4. Just laws of addition. You can write them in different ways. Now lastly, we want to talk about function composition. Function composition is denoted by this little O. Because you say it like f of g. And I guess in math, they got lazy writing the of and just left it with the f-o-g. Now what is function composition? As you see here, if you look at this notation, I have my function g of negative 2 inside my function f. So you have to do some operation of a function first before you figure out the operation of the other function. It's doing one thing inside of the other. Now what order do you go in? Well, f is here, sitting here waiting on the value. G of negative 2 is not a value. So first, we must calculate what the value of g of negative 2 is before we can then assign a value to figure out what is f of whatever that is. So when you see this notation, you want to work from the inside out. Do what you have the number attached to the function first, then the function waiting on what another value is. Now if you see it like this notation, f of g, negative 2, you're going to work with the first one that's associated or next to the number. So this one, you're going to do g of -2 first. So in this notation, do the function first that is next to the number, g of -2. In this notation, first do the number that is inside, because this one's waiting on the value. Doesn't know what it is. Must evaluate what g of -2 is first, and then we'll see where we'll place that function with that value. So here's what I mean. I need to find g of -2. G of -2. What is that? If I were to just give you this as a problem, what would you do? Well, you'll look at your g function, you look at your x's, and you'll plug in -2 for x. So let's go ahead and do that. So I have g of -2 plus 3. -2 times 2 is a -4 plus 3 equals -1. So what is g of -2? That is a -1. Now that we've found this value, we can replace this notation with that value. So let me get rid of g of -2 because I know what that equals. That equals a -1. So I'm replacing that old function with the value of -1. This function here on the outside was waiting on that value. Now that I know what it is, now I can evaluate what is f of -1. Or I'm going to take this value and plug it in for the values of x associated with that function. So that's going to give me a -1 squared plus 4 times -1. This is a positive 1 minus 4, which equals -3. So what is the function composition of f of g of -6? That is -3. Oh, sorry, -2. First, you had to find out what is g of -2, give it that value, replace that value inside of here. Now you have the function f of -1 that you can calculate, get -3. So it's essentially two different types of function evaluation problems inside of one. Now what if you have something like this, where I'm looking for the function composition of f of -2? Well again, this function is waiting on something. I got to figure out what the f of -2 is. So first thing I want to calculate is here, f of -2. What does that equal? Again, I want to plug this value in for all of my x variables waiting on a value. So -2 cubed plus a -2. This is -2 times -2 times -3, 2. So that's a -8 minus 2. So that's a -10. So what is f of -2? A -10. So I found out what that value is. Now I could take that value, this outside function, which was waiting on what that value is, and replace this with my -10. Now I'm trying to find what is f of -10. So I'm going to plug in -10 for all values inside of my x. That's going to give me a -1000 here, minus 10, equals -1010. That was my function composition of f of -2. Had to figure out what is -2. Found it. Now let me replace that with that value, -10. Now I have to find the function f of -10. Here it is, -1010. So let's solve one more function composition, but this time with a different notation. Remember, with this notation, we have to read like our more Eastern cultures. That's from right to left. So first, I need to find what is my f of 2, which for my function x, I need to plug in a value of 2. So f of 2, oops, not sure what I was trying to do there. F of 2 equals 2 squared minus 4 times 2. That's going to be 4 minus 8, which is a -4. So I found my value of f of 2, that is a -4. Now I have to replace this, now that I know what it equals to, in here. Now I need to find what is g of -4. So I look at my function g, I have 5x, so 5 times -4 plus 2. That's going to equal to -20 plus 2, which is a -18. So what is the function composition of g of f of 2? Well, that's -18. Or first, I have to figure out what is f of 2. That was a -4. Then replace f of 2 here with a negative 4. And now I have to find what is g of negative 4. Here, it is negative 18. And I'm done. There's no more other functions to plug in.